This is a classical problem. I think now it will, you'll see it will be more clear. In this case, we have this problem. We need to calculate the pressure difference between two pipelines. We have two fluids. You see, we have the fresh water and seawater. In this tank, we have fresh water. In this tank, we have seawater, okay? And we have four different fluids. So this is one fluid, this is another fluid, this is another fluid, this is another fluid. You can see, I will not write down a lot. And you will get the video solutions for all these problems later on. So this height is 0.6 meter, okay? And this is water, fresh water. What is the density, guys? It is 1000 kg. Oops, it is 1000 kg meter cube. This is the mercury. We have mercury here. It is the density given here. And so up to this, you look here, up to this height is given 0.1 meter when we'll calculate for mercury. Now, this is another fluid. The specific gravity is given 0.72. So what is the density for this? 0.72 into 1000. So 720. I believe all of you know this. I'm not going to explain it. It should be kg meter cube. This height is given 0.7 meter. And now we have the last fluid. It is the seawater. Density is 1035 and the height is 4 meter, 0.4 meter. We need to calculate the pressure difference. We'll say this is pressure P1, this is pressure P2. How many of you can solve this problem? If I tell you, guys, solve this problem by yourself, can anyone of you solve this, guys? Based on our previous discussion, can you solve this problem, guys? I think, yeah. I think if you try, then you can do it. It is not a complex problem. Let me just write it down. What will be the, so if it is P1, if it is P2, can I write it like this? P1 plus, we are going down. Okay, so let me, wait. Oops. Just a second. Okay, so one question, what is SG? This is the specific gravity, okay? Specific gravity. Please, if you check the first lecture, then you will get it from there. So for this one, can I say it is like density of the water, that means rho W, G, and H W. Okay, you see, this is H W, rho G, and H W. Then we'll write this is, then we'll calculate for this part, for mercury. That means we already have up to this. Now for this part, it is, what is the, we can write, the mercury, the gravity, and the height of the mercury. So it should be plus here, isn't it, guys? Because you see, this is the point. So now, how is the directions? You started from here. Now we are going up. So is it positive? No.
Should be negative.
Negative.
Yeah, it's negative. Now it will be again negative for this while. So we can write it as density for the while, gravity, and the height for the while. Now this one, you see, we are going down. It is, now it will be positive. So it will be positive, density of the seawater, gravity, and the height of the seawater, okay? And it will be equal to the pressure P2. That's the formula. And now you have all the values. You have all the values here. The seawater density is 1035 kg meter cube. You know the density for the mercury is 13,600 kg meter cube. Density of the water is 1000 kg meter cube. And the specific gravity of the oil, it was 0.72. So the density, it will be 0.72 and 1000. So 720 kg meter cube. Substitute all the values. I'll quickly write it down because we have limited time. So I will write it because this is a straightforward problem, so we'll not spend a lot of time with this, okay? So density of the water, you just substitute all the values. So this is I can do just kind of a little bit, the left and right hand side calculations, and I can write it like this. I will provide you the detailed solutions later on. So this is the gravity. Okay, I can simply put it like this. P1. Okay, just let me write it, whatever I did. So I can say P1 plus density of the water is 1000. This is 9.8. This height is 0.6 minus density of the mercury is 13,600. Gravity 9.8. At this height is 0.1 meter minus the wall density is 720, and the gravity is 9.8. You can use 9.81, okay? And the wall value is 0.7 plus the seawater is 1035 density, gravity is 9.81, and this is 0.4 meter equal P2. Now, if we solve it for P1 minus P2, it should be, 8340. It is, I can write this final term maybe 8.34 kilonewton per meter square. So what you need